Dun, 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 dun. Oh, hello there. Now hear me out. What do Lord Baphomet and the classical radius of the electron have in common? We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one rule yad. I don't think it rules them all. And it might
Yeah,
be just hyper ruleal turtles all the way down.
Yes, it's on the back of an infinite number of hyperruleal turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. Yes, it's late, but it's gonna be totally worth it, I claim. If this is your type of thing. Alright, so whilst at the monastery, we found out we had some new significant digits. Different measurements. We had concise measurements to the best of our experimental knowledge and technology at this current time. Alright, what am I talking about here? We go to our friend, NIST. That's going to present to us the current code data for the stuff and things to the best of our knowledge. All right, so what do we have here? All right, yes. I highlight it and then I actually wrote it in because I want to use capital letters because I like to capitalize things when I think they're important. I claim. Now, the classical electron race, it's got this number here. So what is it? It's 2.81794033262 times 10 to the negative 15 meters with approximately, 1 and a 3 in the deviation. I forgot to add in the description, this actually confirms some of the HF8 model. That's model for the minimal arena. Why do I say this? Because basically, I had it here in the book, and I used it on the thumbnail. Basically, we didn't have these last two significant digits before, and basically, Thad had predicted 5-0 for the previous, because we actually went through and we found something so much more fantastic to fit the data. It makes a lot more sense, in my opinion. So basically, this new data, it basically confirms this because it was in here. And the beautiful part, like any good knot, as we get more information, the model tightens. It's fantastic. We're going to go into it here. So, hey, Whitechapel, thank you for joining my. I think you're going to like this because we actually we invented a new mathematical constant. Or technically, Thad and Vanessa did. We'll get into it in just a second here. Okay, so that's that thing. And that was why I was showing Lord Baphomet at the beginning there, because essentially he's they because it's ambiguous and or as many genders as you want. But basically, yes, it's an imaginary goat, and that's what we use as the terminal action to figure this stuff out. So what the heck am I talking about? Okay, so we're gonna go to our friend Wolfram Alpha here. What is the goat problem? I asked Professor Wolfram this with no additional context, and he didn't know. So I think it's interesting. So what it is let's say you have a circular section of grass, and you want to tether a goat or whatever grazing animal it may be to basically graze exactly half the circle. So you're like, oh, okay, it's going on. This is an easy thing. Apparently, it is not an easy thing, and I think they literally just solved it like within the past 10 years. Like they kept on approximating because it's not easy. So, oh, okay. It's no. It's okay. It's okay. I'm total. Oh, I forgot to tag him. It's all right. Things we should remember. But essentially, here's what it is. You want it to graze exactly half the circle. And you're like, again, maybe it's easy, but you actually go into it. Yeah, it's all this complicated stuff. But basically, it has. I think they do have an exact solution. At least we can approximate it out to enough significant digits that we need. So what is that? Okay. So the goat problem or bull tethering problem considered a fenced circular field of radius A with a goat or bull or other animal. tied to a point on the interior or exterior of the fence by means of a tether length L, and asks for the solution to various problems concerning how much of the field can be grazed. Okay, so you go through that, and again, oh look, it's a lot of mass. It's a lot of mass. Oh my god, that kind of looks like a cardioid. Oh, God bless the internet. But Jax, hey, welcome, my friend. Welcome, my friend. But all I know is there's a lot of YouTube I haven't explored. Should I explore it? Well, that was part of my quest. You should totally not go see the community video. There's a reason why I don't sing on a frequent and regular basis. But okay, so we have the approximation here. Was it about the radius needs to be about 1.15 yada yada? Okay, so we go to Wolfram Alpha. You can't just type the goat problem and do the full computation like the geese skiing constant. It's unfortunate, but basically, if you just type in enough significant digits, it'll keep going more. Oh, and one of the greatest parts is, okay, its notation is G sub G. It's literally GG. Yeah. Real life is more interesting than fiction. Or at least very often. Okay, what is GG? It's a tether lane in which a goat can be tied to the boundary circle. Yeah, we click on that thingy. Yeah, basically it leads you to the goat problem. Okay. So how does this work? How does it actually make sense? Okay. We're going to try to make sense of this. So remember, we have a hyperbolic vortex equation right here. Okay. So this is the whole 1 over x plus x cubed, and you divide it by 2 pi. That's a circle. So you kind of get a big twist there. When we set it equal to I raised to the I, that's the imaginary unit I raised to itself, or raised by I, and that's raised to negative pi divided by 2. So basically, you got a circle, a smaller twist going the other way. And we set it equal to the Planck. This is actually should be the Planck mass gap here. So basically, that's the gap in the mass for the Planck boundary. That's the number here times 10 to the negative 8, yada, yada, yada. Okay, the terms we're going to be using here are the last two answers. This comes up differently for me than Thad, and it confused me a lot. So basically, the one with the positive 4 here, this is just 3, and this is just 4. That's he basically, it's Cyrillic. He gives it the notation. It looks pretty cool, at least on the book and everything. It's a little different symbol than X. It helps you to figure out because you can use whatever symbology you want. I just happen to think this is pretty beautiful. But well, my thing is, well, the memes are great, or at least I think I'm required to say that utilizing my YouTube handle. But ultimately, the truth is the ultimate defense. And if this is true, and again, to my knowledge, this is the second. This model has 2 more confirmed predictions in string theory now. I'm just saying, take that for what it's worth. But okay, so we have those answers. That's important. We have that goat ratio. So now behold, the imaginary goat ratio. I suppose you could just say this is we're subtracting it here, but this is what we have. It's negative I times the goat problem. That number we get is, excuse me, negative I times the square root of the goat problem answer. Because essentially Thad had created it was like negative the square root of negative GG. Vanessa's like, he had to come down and look at it. She's like, why don't you just pull the I out? It's like, that makes it more beautiful. It's like, oh, I was like, I think joking like Schrodinger's goat, and Thad's like, it's an imaginary goat. I'm like, oh my god, it's so dumb. Done. It's the imaginary goat ratio. Again, silly names have a very strong place in science, I claim, because we can't forget the internet helped give us the SS Bodie McBoatface. It's that navigational vessel that I think was exploring the South Pole. It's so lighthearted. It's so descriptive. What the internet can call it? Bodie McBoatface. Why? Because we can. Now, Okay, we has these numbers here. We have their imaginary goat ratio. And since I couldn't put all the characters into Wolfram Alpha, I'm starting to learn how to use the notebooks. I nearly crashed it the other day doing different stuff. All the videos I'm going to show. I think you guys are going to enjoy it. But, okay. So we have our imaginary goat ratio. The negative I times the square root of the goat prom here. Those are these digits right here. Boom. Okay. So, and then we got Je3, and we minus, oh yes, this complex actions there. They're two-dimensional components. It's fascinating. Okay, that gives us this number here. So we take that number, and then we plug it into this monstrosity here. What is this monstrosity here? This is what, let's take a look. Let's take a look before we make any claims and stuff. Okay. So this is actually Je1. This is essentially, when you square that, basically you get what we colloquially call the fine structure constant. And that number is right, say Je1, 0.085424, yada, yada, yada. Okay. So we square that. We get the fine structure constant I claim right here. Okay. And then what do we have here? This is part of our primary action. So the primary action is actually Je1 squared. We square it. Fine structure constant. It's the geometric number we use. And then we multiply by the boundaries. Again, this is from the universal binomial factorization equation. This is basically how we calculate most everything in the model. But, that's bad. I see what you did there, Nolan. I see what you did there. I'm going to create a card for it because I'm literally going to put the information for it. We're going to meme this into reality, or at least I'm just going to put it out there, and whatever happens, happens. But, all right, so the boundary conditions for this particular action are we get the Planck length, this time the Planck mass, and then we divide it by the mass of the electron. Again, we've got done that in previous videos, so it could help build up this tower of explaining different stuff and things in reality, at least to the best of our knowledge. And then we have 1 plus, this is the terminal action. This is the thingy we got right here, that 8.75, yada, yada, yada. It's the geometric number we have there. And since it's divided by the 10 to the 7th, that's our inverse symmetry scalar, or whatever. I keep changing the name. It's that 10 to the negative 7 number, basically our hinge point. So the terminal action often is quite small. Now, the size of that terminal action may vary. So that gives us this number right here. All right. So what is this number? This is 2.817. Okay. 2.817. Okay. 940. 940. 3261. 3262 with error bars of 13 for the last 2 significant digits. So we are off by literally 1 there. I think that's pretty good. And at least, again, I am not a professionally trained physicist. I've not gone the normal route. I'm a dude that spends far too much time on the internet, but has been blessed to have a lot of great conversations and learn a lot from many smart people. But my friends, this appears to be a geometric derivation of the radius of the electron. Classical, that is. Now, again, this is to the best of our measurements. Maybe it's not right. Maybe it's not right. But again, the more data we have, the better. Because, well, if you're going to attempt to hack reality on a MacBook Air, full disclosure, there's a MacBook Pro. Wouldn't you want to have like the best information you have? And if you get new information and that's different, okay. That's what why wouldn't you update your priors? It's like, oh, we thought it was this. Well, we've got better measurements. Did the experiment work well? Has it been confirmed? Can we reproduce it? I think this is information we should have out there. Why? Well, if we're on the road to universal replication, I think that would solve a lot of problems. That, and I tend to agree with Dr. Weinstein in that. Yeah, I think we should diversify our portfolio of places humanity exists, just in case. Not even with us. If a really large rock comes, all I know is 2019. A bunch of smart people came together and we ran two emergency drills. A whole bunch of folks from like around the world. One was a plague, the other was a space rock. Now, history seems to play it out. We did not deal with the first problem well. We totally also failed the second problem. We failed both those in the simulations. I'd rather really not have the second one happen. I'm just saying that these are things that just things to consider. So, but that's all I got for right now. Peace out, everybody. Be safe. It's a wacky world out there, but I think we're starting to figure things out. Why? Well, this is why I asked what's going on. I don't have an idea, but I think I'm starting to get a little bit better at it. So, peace out, everybody. Take care of yourselves, y'all. Where's the thing? Where's the thing? I went past the thing. Oh, there's the thing. Take care.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.